Just like vector subsetting, we can use the same techniques for matrices. These methods include subsetting by index, by name, by logical vectors. Let's begin by looking at the first method, extraction by index. First, let's create a matrix and call it Z2. This matrix is a 3 by 3 matrix. Okay, we can even check the dimension using the dim function, Z2. Okay. Next thing, we need to add the labels, and these labels we can add them using the row name function for rows and call names function to add the labels on this matrix Z2. Let's go and add them. Then we can see the output. Now we have the column labels and the row labels associated with the values. Okay. Now let's look at how to, so suppose we want to extract elements from this matrix. And in this case, we want to extract the first row and the first column. Let's go here. First row is this and first column. So the value is 1. So how do we extract that? We use this convention, row, comma, column. So this will be by index, by the integer location. So just say 1, 1, that intersection, first row, first column. Then we get this value here. What if we want to extract a third row here and maybe second column? All we need to do is just to say here, that will be third row, remember, that's the row, and second column, right? If we extract that, we should be able to see a value 6. There you go. So that's pretty straightforward. But now if we want to extract multiple elements, we use the same convention here, but we can do something different here. Okay. So for now, let me just comment that out. Let me see this works. Okay. So if we want to extract maybe the first row and the second row and keep all columns, how are we going to go about this? So we can specify here, first row, use the column, right? Comma, and we can just leave this open. We don't put anything. We do that, you can see the first row, second column as first row, second row, and we extract all the columns. We can also extract the first column and the third column, right? So remember, these are different. They're not following each other. So how do we do this? And want to keep all the rows. So this will be the opposite of this. So we don't put anything in the row part. So we just say comma. But now for columns 1 and 3, we can use the C function, right? C function, because say first column, comma, third column. That way, we're able to see something like this. So first column, third column. Okay. And you can see here. We can also say here we want to extract the first row in the third column using the C function. Okay. And clearly that will be just extracting both rows. So you can go ahead and say C first row and third column. Okay. Similarly here, we could also say we just want to extract second column up to the third row. So we use the column if they are consecutive, following each other. Okay, so you can play around with this, slice and dice, pretty much simple, and we'll use this a lot when we start looking at data frames. Also, you can use the names to subset our matrix. So we already have the column. Okay. And by the way, you can actually click this icon here. It will open up you know, a very nicely formatted Excel kind of looking like matrix. Okay, let's go back to our script. So the same thing here, this is just the same as doing this, but by using names, right? So suppose we want to just extract the first row and the second row. So we use the name here, 0, 1, 0, maybe we could say 2. Same thing for column 1 and column 2, we can change that to 3. So you can slice and dice however much. So you can see here, we just extract the first row, second row. You can change that maybe to third row. And here, column 1 and column 3. Well, we can change that again to maybe first row, third row, first column, third column. It's easy as that. So try different, permutations here. Okay. Then we can also extract by name. So here is a real-world example of 2022 medal table for World Athletic Championship. So these are the top 5 countries with the most medals. So we can construct a vector and we call it countries. Okay. And then we construct a matrix calling it medals, right? But now the data here, these are actual values for gold, silver, bronze, and total for each country. So for instance, these first 4 represent the elements for USA. So 10 here means gold, silver, bronze, total, to correspond with gold, silver, bronze, total. And that's why we specify that when 4 columns to represent the labels for this. In fact, dim names here, it's a very important method because unlike raw names and raw columns or col names, the dim names here can add both the raw labels and column labels simultaneously. So again, here we use a list function to combine these labels for rows and these labels for column. Okay. So let's construct that. All right. Now we have a very nicely formatted table over here. So again, we use the same principle here. If we wanted to extract different columns, let's say we want to extract from Ethiopia to maybe Kenya, right? Second row, third row, and we want to extract only the gold column in the bronze column. So we can just do that by using these numbers. Okay, that's what you're saying here. You can see we have a nice table here that we've extracted from here. Okay, we can also do by names. So if we wanted to extract a country like China here, okay, so this is for the row, okay, and then we leave this empty, meaning we want to see all the columns. Okay, so you can use the same knowledge you've learned right now to apply on this as well. It's the same thing. So here we use the C function if you want to try different things. So in fact, here we don't need to do that. We can just say 2, 3. It's the same. We can use a C function if you want to have different numbers here separated by a comma. Okay. Then lastly here, extract by logical vectors. Again here, a logical vectors, meaning that we can use logical operations like greater than, equals to, and so on and so forth. So let's create a matrix X, has elements, integers from 1 to 12, and has 4 rows as shown here. Okay. So logical here is the same thing as using true, false. So here, what you're saying here, we want to extract the second row. Okay. Why we know it's the second one? Because here we decided to make it true here. And then here, this represents the columns. So again here, that means the first column is true and third column is true. So we want to extract data elements from the second row, first column, and third column. So let's run that. We can see 2 and 10. 2 and 10 corresponds to this and that. Second row, first column, second row, third column. Okay, it's the same thing as using indexing. If you use indexing, it's just say second row, and then for column, first column and third row, you get the same output. Okay. Again, let's just run that metals. So we can say we just want to see all the elements that have the column name gold is greater than 2, for example. Okay, so an entire row. So we'll see that we'll just extract that US and Ethiopia satisfy this condition. All right, this condition where gold is greater than 2. And remember, you can change this to anything else, right? You could say bronze, for example. Okay, so these are valid questions as a data analyst. Okay, but now we have a problem here. So the total is still appearing here. Okay, we don't want this. So how do we change this? Okay, so much of your time we'll be spending to do some data preprocessing. So to modify that, okay, we can say we want to exclude. So this is the same code here, but we can say we want to exclude the last column. So we just use the minus sign. So this is the fourth column, 1, 2, 3, 4. So we're telling R, remove the fourth column. So if we do that again, see, we have a nice table now minus that. Okay. And then based on that, we can even save the output or the results here, maybe to new metals, for example. Okay. So that we can be using it now. So that table now, this table of matrix doesn't have the column there, and now we can ask different questions. So for example, here I could say I just want to find rows of all metals that are greater or equals to 3. Okay, it just returns Boolean here. Okay, but if you want to do some subsetting using the square brackets now, so I could just copy this, for example, over here. Okay, and I could just say new metals. Okay, and here maybe I want to just have gold, for example, maybe greater than maybe 4, for example. Okay, let's see what we have here. Say logical script too long. So what that means, this is actually a good use case to see how to debug this. So we have to match. So remember, we chain this to new metals. So here I think we also need to also chain this to new metals, right? So that we can access the same. You can see this satisfy that condition. So that concludes this content on subsetting matrices. We've seen how to extract elements by index, by name, and logical vector.